I just think they don't have this much. Alright, chapter 7. This is our last chapter. It's only February, because we finished by Stephen. And after spring break, it's all AP. I could get it to talk about, so let's not talk about it. No. Okay. We talked about this already, but in chapter 7 we're really going to talk about that the integral is a tool that can be used to calculate net change and total accumulation. Kind of like the pizza problem, right? Like how much the change of... Oh, look, it is. So, if we talk about the position function, we always talk about the position function as S of t. We haven't talked about position, velocity, acceleration, jerk in a while, right? But if we were given the derivative, we could talk about that we could determine where the particle is moving left, where is the particle moving right, and where is the particle stopped. How could I use my derivative to know when a particle was moving to the left, or moving backwards, or falling? Yeah, when velocity is negative, right? So this would be when ds. How could I find when the velocity when the particle is moving to the right, given the velocity? When it's positive? And what do I know about the velocity when a particle is stopped? That's really not a new concept. Maybe we don't usually think of it like this, but... If I don't grade it for correctness, then you're not going to try it all, right? It goes to the next one. But it's correct. I grade the whole thing. It goes 4. And it's the first one. Like the free response, multiple choice is easy to grade, right? Free response takes, for the first one, you can just completely do it. I don't like we're supposed to be speaking that we're growing, right? So we do the first one before we do the review. Then we review a lot, so hopefully I can show you how to figure it out. Well, no, kind of to show that you've grown. This class used to be my SLO class. Like I had to set a goal of how many people were going to pass the test. Like my evaluation or my evaluation but then you have this targeted objective. So my targeted objective is only to show that so that if you don't pass, you'll be like, well, look where they started and look what they did. Okay. Velocity is given in meters per second of a particle moving along the x-axis. Use analytic method, that means not the graphic calculator, to determine when the particle is moving to the right, to the left, and stops. What function are they giving me here? Oh, it's the velocity function. So if I want to find where it stopped, what should I do? Right, where it stopped is where the velocity equals 0. So I can just set this equal to 0. And really, so much of the AP test is being able to think through a question and just be able to think, what do I do here, right? Our brains are so into derivatives and integrals. We always think we have to take a derivative or an integral. This is already the velocity function. So we just have to set it equal to 0. So right side of me driving all around. Like the estimate back here is really got floating good in my height is on. I wouldn't say good actually. I would say like I don't think it would right? Like there's like I'm never gonna learn all the rules of basketball. And I'm never gonna be a good singer. I'm never gonna be able to dance. I can do calculus. I can cook pretty well. Well, that's not. So t equals 5 and stop. How can I figure out where it's moving to the left and moving to the right? No, without a graph. They're telling me I'm only going 0 to 10 seconds anyway, right? There's 0. I got 5. I got 10. Remember back in the day when we used to take the derivative and then set it equal to 0? To find max and mins, and we plug it in to see whether it's positive or negative. Oh, we already have our answer. It's 35. Like, we know it stops. That's what we used to do, but isn't the velocity already the derivative? You see what I'm saying? So I just need to see, like, what happens when it's moving to the left? What's the sign of the velocity when it's moving to the left? It's negative, and when it's moving to the right, it's positive. So could I just plug in values to see whether it's positive or negative? Yes. Half of our AP exam is without a calculator, which means yes, if you graphed it, you could look at it to see. But without a calculator, you have to know, oh, I can just plug a number in there into the velocity. And if I plug 1 in there, am I going to get a positive number or a negative number? Yeah, 49 minus 9.8 is positive. And if at 5, that makes that go to 0, that means 5 times 9.8 is 49. If I plug a number bigger than 5, what's going to happen? That's going to be bigger than 49, so 49 minus something bigger than 49. Which is what we've done, what we did a whole lot of first semester talking about maxes and mins and all this stuff. It's just another type of problem. Instead of talking about maxes and mins and increasing and decreasing, they're using words like moving to the right, moving to the left, and stopped. And so we can say it stopped at 5 seconds. Because the velocity is positive, we can say that it's moving to the right. Be really careful. It's why it's really important to make sure you pay attention that we start at 0. We're talking about time here. So it's moving to the right from 0 to 5. So you could write that like as an inequality, right? And we always have this debate, right? Do we include 5 or do we not include 5? It's debatable. But I'm good with that. And then moving to the left from 5 to 10. 0 and 10 would be included though, right? Because at 0, it is positive. At 10, I didn't include it. So I definitely think I include those. Again, on a free response question, the point where it changes, it's either way. You can kind of use a bracket. Multiple choice, there would never be multiple choice. So. So what if we talk about the position now, right? So part A is really just talking about max and min. The first derivative test, really. I'm going to double it. Think about this, okay? So part B says, what is the position at t equals 10 if f of 0 equals 3? And then they ask other questions here too. So if they give me velocity and I want to go back to position, Grady, what did you say I have to do? Yeah, I have to go backwards. I have to take the integral, right? So if they give me position and I want a velocity, I do derivative. But if I want to go backwards there, if I want to find the position, I'm going to do the integral. I want to find the position at 10 seconds. So I have to set up a definite integral there, right? what are my bounds going to be? 0 to 10. And like you can write it like this, and we're going to talk about this over the next few days, that on the AP exam, I'm going to fill actually the actual number in a minute, but on the AP exam, especially on the free response part, especially if it's a calculator part, people really want to skip over the writing down the part so they can just type it in their calculator. But you have to write the integral. You have to show that you're writing it. You don't necessarily have to rewrite the whole equation, but show that you're taking the integral there. This is kind of very much like the pizza problem of, if you do this, it's going to tell you how much it changed from 0 to 10. But you have to take into consideration where it started, right? Like on the pizza, it started at 350 degrees, so you have to take that into consideration. So I say we're going to add plus, the book calls that the displacement, I call it the initial value, where it started, right? So I'm going to say plus s of 0 right now, and then I'll actually put it in here. Or you can put it out in front. S of 0 plus. Oh, look, actually, we're going to match that to be s plus. Placement is how much it changes. So, s of 0 is just 3, just like the pizza problem started at 350. You had to add that into your answer. And the 0 to 10, the displacement is how much it changed from 0 to 10. So just what happened between 0 and 10, not considering where it started to begin with. Okay? So then I'm going to actually do this integral here. And again, we kind of want to have this balance of when do we use our calculator and when do we not use our calculator. Would they give you something like this without a calculator? Probably not, even though it's not that terrible, but it's just a little bit of computation here. So it's kind of up to you on how much you want to practice. If you feel like you need to practice with your integrals, then definitely do it. It did say with analytic methods, which means I think they were expecting that we were going to do this. So I would get what? 49t minus 9.8 t squared over 2. Do you agree with me on that? From 0 to 10. Not 3, the 3 is just extra plus 3 and 10. 0 is a great amount to have, right? So I plug 0 in there. So 3 plus, if I plug 10 in there, that's going to be 490. Right? Plus 10 squared is 100 times 9.8. Which is and then I'm going to just put a big minus 0 here. So 490 minus 490, do I just get 3 as my answer? That's not true. But what happened on this one? What happened? It actually moved between 0 and 10. But what happened that ended up canceling out? Yeah, like it just undid what it did forward and backward. So we call these initial value problems. These show up a lot on the AP exam. Find the new position. So make sure, right, we're going to do a lot of practice with this in this chapter, but you want to make sure you read what it's asking, because then they could ask you another part, right? Look, we're still on question 1. Part C says, find the total distance traveled. Look, I covered that up. I told you how to do that yet. So the total distance traveled from 0 to 10. I don't care where it started now. I just want to know, during those 10 seconds, how far did it move? The total distance. So when you see that word total, you're going to do absolute value. And if it's a calculator problem, remember that you can just type that in your calculator, 0 to 10, the absolute value of b of t. I never know if my teacher can type that. Yes, but don't do that yet. Math 9. But you can do absolute values first and then Math 9. And your calculator gives you the absolute value. There have been pre-response questions like part C that say find the total distance. And you write it out like this, and you hit equals, and you type it in your calculator, and you get the answer. You gotta show the setup though. Don't just show the answer. You gotta show that you did the absolute value. So they want you to know that total distance. If this was without a calculator, remember with absolute value, you have to break it up by the 0, right? If you don't break it up by the 0, you're still just gonna get that it cancels out. So without a calculator, you have to break it up at the 0. So you're gonna have to do from 0 to 5, 49 minus 9.8. Absolute value. And the integral from 5 to 10. Because you have to break it up at the 0. Right? So it's kind of like we already did the integral over there, right? So it's just putting the numbers in. And we really already did it for 0 and 10. And remember that you take the absolute value of each part in between. Nine 9.8 divided by 2, isn't that 4.9? So from 0 to 5, and then I'm going to do the same thing from 5 to 10. The mistake that people make is they take the absolute value at the very end. But remember, this is absolute value added to this absolute value. That would be 49 times 5 minus 4.9 times 5 squared. Plus 490 minus 49 minus 90 plus 4.9 times 5. And let us just count too much. So remember that I'm distributing I'm doing f of b minus f of a. So 49 this would be I think we should erase that. That minus 49 times 5. Sometimes talking and writing is really hard. On a test, for me especially, you know, show some work so that if you made a silly mistake, I can see that you had the right idea, that this was something like I did. Should kind of know, expect what's going to happen here. If you know what's going to happen. What happened earlier with the net? Like, what happened between 0 to 10? Like, we got that the new position was just where it started, which means it just canceled each other out. Which means if we're doing the total distance, what should happen is this should be the negative of this, right? Like, when we break it up, because it should cancel each other out. You should get negative 1.2.5 there. Plus 1.5, which is why the net movement is 0. But the so the total distance traveled. So, because earlier on part B, we found that the displacement, what happened between 0 and 10 seconds, we got 0, right? So that means between 0 and 10 seconds, however far it moved positive, it moved the same amount negatively, right? So like that canceled each other out, like the area canceled each other out, which is how I knew when we were doing the total distance that I should get the same thing, only one positive and one negative. That's the only way that I could get a net movement of 0. But total means you do the absolute value. So a big part of this section is just knowing the directions and knowing whether you're doing the integral or the absolute value. Knowing whether you're using a calculator, whether you just type in absolute value, or you have to break it up by the zeros out of the calculator. But again, 100% sure that this kind of question is going to be on the AP exam. So I just kind of summarized this for you here. We can write some stuff out here. But when you integrate the velocity function, that will give you the displacement. What happened over that time period, which I said is the net area between the velocity curve and the time axis. So we can say if we integrate from A to B of B of t, right? That's going to give you what happened over that time period, which is just the area under the curve. If you want to find the new position, right? If they don't want to know just what happened from A to B, they want to know where is the particle now, you have to add in that initial value. So that's where I'm going to say that S of 0 plus A. And if they talk about total distance, right? Remember that total, just count the whole movement, positive and negative, just make it positive. So that is your absolute value of your velocity. Value. So your job is to distinguish between the directions here and what's doing. So much of calculus, I feel, is understanding what the directions are asking, especially on the AP exam, because when we take our little, practice stuff that we've been doing for chapters, we really choose almost all things after the chapter that we're on, except for that part C4 that we have. But for the most part, it's just what we've been doing. The AP exam is going to have everything from that we started in August to what we input now. And so you have to really look at what strategy should I use here. So, here's your homework. I don't have any assignments for you yet. But I want you to get your paper out and label it, and we're going to talk about number 1 because it's intriguing. Maybe we should use How are you? Good. But isn't it off the, like, squiggle sheet? might want to open your book and like read directions. You know what's really great if I happen to stay at school? This is the chapter that I really wanted before I which is that you know happen. And so like I have really good recording of what I thought. But now a lot of that. No, I mean like they didn't collect homework. Like they assigned homework, but it was never for a grade. And they did it. Like my classes were almost all just technical. So the directions for A, B, and C are just like the spreadsheets that we did, but I just thought I would help you get started on this just because, you know, it's great. We haven't solved equations in a while. It's one of those things. Which is why you're not doing the brain reading. So if you're trying to find where the particle is stopped, moving to the left and moving to the right, one, for trig, you can maybe just think about what happens with cosine from 0 to pi, you can figure that out. But you could also solve that equation of if I want to find where it stopped, and I can divide the 5 over, right? So it's still like saying cosine 0. So you have to use your same. And they are only 0 to 2 pi, so pi halves and 3 pi halves would be places where my velocity is 0. Again, you could actually think about what the graph of this looks like to help you. You could also just think about the unit circle. Think about the sign of cosine. From 0 to pi halves, is cosine positive or negative? And then what happens from pi halves to the next time that it stops all the way down here at 3 pi halves? Is it negative on both of these? So this is negative and this is negative, which is why we don't even need pi in there, right? We can jump all the way to 3 pi halves. And then what happens from 3 pi halves back to 2 pi? Positive, right? The graph of cosine also looks like that. It starts up positive, and then at pi halves it's going to go down and be negative until 3 pi halves, and then come back up. And so then you need to write your answers. You need to say, where does it stop? And then you need to either write intervals or inequalities to tell me where it is moving to the left and where it is moving to the right. You're going to write for the left. Like, when's it moving to the left? From what to what? From pi halves to 3 pi halves? Right? And you guys wanted to not include it, right? I want to not include it. I don't know. So the left is easy because it's just pi to 3 pi, but the right you're going to have 2 intervals, right? Because you have to go from 0 to here and from 3 pi halves back to 2 pi. So you should have 2 intervals where it's moving to the right. And then from there, all that. You tell me. Oh, so 0 and 2 pi we should include. But from pi halves to 3 pi halves, those are both stopping points, right? Like that's where it equals 0 already.
Yeah, but like.
Yes. A, when you thought part B and part C, just like what we did in our notes. And then 12 through 16 are all about a picture that they gave you. You're supposed to still think about the integral. And what I want you to do on 12 through 16 is please show me like what kind of integral you'll be taking. But then you should be able to get all your answers, because remember, it's still in area. You should be able to get your answers straight from the graph. We'll talk about some of this tomorrow and how you want to show that on the exam. How you want to show your work. Okay? And then we'll put another day on it. And then I haven't figured out for
so on that graph,
it's not bad. What I want you to do on 12 to 16 is write what intervals you can take, right? So like, and we'll talk about this tomorrow, but like, if you're going from 0 to A, like say that, and then you just look at the picture to get your answer. Just because on the AP exam, you get points for the setup of the problem, and so don't just write an answer on 12 to 16 if you can. And we'll talk about that more tomorrow. But yes, the idea is 12 to 16 is not really as much computation as one thing. Mrs. Douglas says that every school looks like itself. Well, but North of us is supposed to be this. It's like, and so Mrs. Douglas said, I think we're going to get out early, and Mrs. Todd let us. I don't either. I said, Boston said he thinks it's going to be pretty good for Boston.
What they said last night was that
he said yes. Boston said he thinks it's not going to come to anything, so it's like right on the line of like getting 6 inches of snow or just 1 inch. So it just depends on the temperature and it just depends on where it actually. And then it's off. So I'm always on. I know about it like 2 weeks before because Mrs. Hot told me.